Hello and welcome to another tutorial. We are going to continue our discussion on classes and objects. We looked at the details of creating classes, how to declare them, and then how the Java compiler compiles your class definitions in the source code, creates the class file, what's the meaning of the fully qualified name, and why do we use packages, and the most important topic of access modifiers for accessing the types, which was which classes are allowed to actually access the type of your definition, like if you're defining a class or an interface, anything in a given package, right? So you have the concept of access modifiers for your type, and then access modifiers for the state of the objects, including the constructor. So you may decide to basically make the constructor private, but the class is public, which means everybody can access the type, but nobody can basically create an instance of that type. And we said that one use case is when you somebody wants to define a method that takes a parameter of your class, even if that class or type is another package. As long as that type is public, people can write methods that accept parameters of the type. And the reason we need this because Java is a statically typed language. So if somebody wants to have a method that takes a particular variable, that variable or parameter has to be of a given type, right? So defining the methods, and this is the second topic here. So it's a very short topic. We've looked at a lot of examples so far on how to define methods, right? Methods define the actions that we can do on basically on a particular object, basically an instance of a class. And we said that methods, just like the fields of a class, can be static and non-static. Static methods don't associate with the state of the particular object, they only associate with the class by itself. That's why static methods cannot have use any non-static fields inside them, right? Static methods only allowed to access the part of the class that is defined as static. Here is an example of a typical method declaration. So you first declare the access modifiers. We said that for methods, public, protected, private, or no access modifiers. So if you don't write anything, it gets the default access, which is the package level access. And again, that was the concept of packages. In the package, we group a couple of classes or a couple of types that are defined in a couple of source files, right? Right now, I'm showing you the packages that basically that are in the source. These are the source files. But obviously we said that if you have multiple class definitions in a given source file, then the Java compiler creates a separate class file for each one of them and puts them in the same package, right? So in fact, you might have, like in this case, I have, let's say, 5 source files in this package, but when the things get compiled, maybe I have, let's say, 10 class files, right? Obviously the best practice is to have only one class definition in each source file, and obviously we said that that class either has to be public or no access modifier, which means package level access, right? But regardless of what access modifier you have, each class definition will be compiled to a separate class file. And so yeah, so in the Eclipse, in this outline or project explorer, it shows the source packages and the source files, but in actuality you have to be thinking about the binary files or the class files. All right. And defining a method. Here's an example of a typical method declaration. So access modifier, and then the return type, and then the name of the method. And we said that the best practice, the convention of naming is camel case. So the each word, if the name has multiple parts or it consists of multiple words, the first word has to start with a lowercase letter, and then the later words have to start with a capital. This is called the camel case naming convention. And then we have the list of parameters. A method can take, usually it takes a finite number of parameters. And again, each parameter has to have a type associated with it. It's either primitive or a class or a like type. So it's either primitive or a defined type, like a class or interface or enum, anything. And again, the rule is that primitives are obviously accessible to everybody, but the types like interface or class, people can only define the parameter type as that particular type if they have access to that type, which means that type has to be public or this method has to be in a class in the same package, right? So primitives are always available because they're built into the language itself. But the user defined types like classes or interface, you have to first make sure that a class that defines this method has access to those types, right? And again, this whole business is because Java is a statically typed language. So if you want to have a parameter and pass it to a method, the compiler needs to know the type. And then the compiler enforces the access modifier rules, right? So it first checks if the type, your class that has this method definition, has actually access to that type, right? And then the next thing that compiler checks is that inside the body of this method, right? If you have a parameter of a given type, like a class type, it checks whether you have access, you are allowed to access the state or which parts of the methods or the fields of that particular class type. So compiler always enforces the access rules, right? Now, there are also other modifiers that might be before the name of the method. One of them is abstract, so public abstract, and then the return type. And we've briefly looked at the abstract methods, which is basically it tells the compiler that this method should not have a body, not even an empty body. Again, we discussed this before, but I'm going to mention it one more time. This method has a body, and it's called an empty body or empty implementation. If you don't provide this pair of curly braces, and after the end of the round bracket you immediately write a semicolon, it's a method that doesn't have any body, not even an empty body, right? So an abstract method doesn't have a body. After the declaration of the parameters, you have to immediately terminate with semicolon. Another type of methods is native. So if you say public native double, which means, again, this is similar to abstract method in the case that it shouldn't provide a body. After the round bracket, you have to terminate with semicolon. But then native is special in the case that JVM tries to look for a class definition in a C++ source code. So usually you write your C++ code, compile it, create a dynamic library, and then JVM can, in fact, load that dynamic library and then associate a given native method with the implementation in that binary file in that dynamic library, right? So if you're not familiar with what native methods are, I have a very detailed course on Java native interface. It's more than 30 hours of lectures, so definitely get your hands on those lectures and learn about how to use native methods, right? Now we can have also public static methods. So public static double, and again, static means this class, this method is not associated with the state of the object, a particular instance or a particular object. It's associated with the class itself, right? And it can take parameters, you can work with them, but then you don't need to have a particular instance of a class to be able to call the static method. You can directly call a static method without creating an instance of that type, right? So defining a method, here's an example of a typical declaration. The only required elements of a method declaration are the method's return type, the name of the method, don't forget to use a camel case notation, a pair of round brackets or parentheses, and body between braces. So you use a pair of curly braces and then you put some code here. You are perfectly allowed to not put any code here, which is called an empty body. But if the return type of your method is not void, the compiler expects you to have a return statement and you have to return something. The only time that you're not required to return a type is when the return type is void. If you set it void, then you are perfectly allowed to have an empty body without any return statement. Because when the return type of your method is void, the compiler doesn't expect you to return any type. In fact, if you have a return statement that you're returning something, you get a compilation error. So more generally, method declarations have 6 components in order. Modifiers, again, access modifiers such as public, private, and again, as I said, there are also other modifiers like a static, native, abstract, right? So not only access modifiers, but other modifiers that you will learn about later. The return type, which is very important. Every method in Java has to have a type for its return value, and the compiler at compile time checks for that. The data type of the value returned by the method, or void if the method does not return a value. So if you write void as the return type, then the compiler makes sure that you don't have any return statement. You can have an empty return statement, that's allowed for a void return type. But if you say return something, then because any anything that you return from a method has to have a type, right? And none of those types are compatible with the void. Therefore, you get a compilation error. But if you say return semicolon, it means now this return statement is compatible with a return type of void, because you're returning without returning actually any value, which is compatible with void. The method name, the name of the method, the rules for field names apply to method names as well. So it cannot start with a numeric literal, and you should follow the camel case notation, but the convention is a little different. The parameter list in parentheses, so you have usually a finite number of parameters, and then the name of the parameter and the type, and again the name of the parameters also typically follows the camel case convention. A comma delimited list of input parameters. Obviously this is very similar to other programming languages, which you separate the parameters with comma. I believe this is a universal rule for all programming languages. Whenever you have a function or method, you separate or delimit the parameters with comma. The parameter list in parentheses preceded by their data types. Again, Java is a statically typed language. Every parameter, the compiler and the JVM, both of them need to know the type. And then if there are no parameters, you must use empty parentheses. So a method can have no parameters, which means you don't need to, when you call it, you don't need to pass any parameters to it or arguments to it, but you are forced to write the empty brackets or empty round brackets still, because that's the signature that differentiates a method from a field. A method is always accompanied by a pair of round brackets. Either there is no parameters inside or there are some parameters. An exception list, so if a method can throw exceptions, then after you finish declaring the parameters, you say throws, for example, this exception, the other one, right? And we will look at this topic later on, but exceptions, methods can throw exceptions. The method body, again, empty body. Method body means the method defines a scope or declares a scope, which is the general rule is that any scope is declared by a pair of round curly brackets or curly braces. Enclosed between braces, the method code, including the declaration of local variables, and goes here, and eventually you have to have some sort of return. If it's void, you don't need to write a return statement. If there is something like a double, you have to return something that is compatible with type double. Modifiers, return types, and parameters will be discussed later in this section. Exceptions are discussed in a later section. Definition. Two of the components of a method declaration comprise the method signature, and this is very important. And again, if you are familiar with the more advanced topic of Java native interface, that's when you have to be very careful about method signature and what it actually means. So we said that there are many parts like modifiers, return type, name, parameter types, and etc. that define the method, but there are only two pieces of information that actually define the method signature as the way the Java language defines it: the method's name and the parameter types. So the method signature means the name of the method and the parameter types, not the parameter names. Remember, parameter names don't mean anything in Java, because in the bytecode there is no mention of the name of the parameters. It's just the type of the parameters. In the bytecode, the only thing that matters for JVM is how many parameters, and obviously the order of parameters matter, right? So in which order the parameters come in the round brackets, and what's the type, and how many parameters we have. So in the bytecode, you never see any mention of the name of the parameters, for example, right? So obviously the surprising thing is we're saying that method signature means the name of the method and the parameter types, right? So here the name of the method and the type of parameters, and obviously the order also matters. So it's not just the type of parameters, the type of parameters in the order that they appear. So double int double double, if you had, for example, double double int double, it defines another method because it's a different signature, right? So method with unique signatures are not allowed. You can only have one method with a given signature. Now the surprising thing here is that the return type is not part of the method signature, and that has implications when we look at the concept of method overloading in Java. So Java allows method overloading just like C++ that allows method overloading or function overloading, But overloading of methods is only based on the signature of the method. And again, the return type, the access modifiers, whether it's a static, native, doesn't matter. Those don't get included in the signature of the method, which means when you're overloading methods, it doesn't matter if the return type is double or not. If you have the same signature of the method but different return type, that's not allowed. You're not allowed to have the same method signature but different return types. That's a compilation error. Every method has to have a unique signature, and the signature doesn't care about the return type, the access modifiers, whether it's native or abstract, etc. It doesn't matter. It only looks at the name and the parameter types in the order that they appear, right? Naming a method. Although a method name can be any legal modifier, code conventions restrict method names. By convention, method names should be a verb in lowercase or a multi-word name that begins with a verb in lowercase. Again, Camel case naming convention, followed by adjectives. And the reason we emphasize on the verb is that methods are the way that we declare actions on the state of the objects, right, or classes. Therefore, it makes sense that we the name is such a way that it implies some sort of action. In multi-word names, the first letter of each of the second and following words should be capitalized, and it looks like they're not going to directly mention the name Camel case, but that's the naming, that's the name of this kind of convention, Camel case notation, which means the first word is all lowercase letters, the rest of the words, the first letter starts with the capital letter. So run fast, get background, get final data, compare to, set x, is empty. These are all the best practices of the conventions that follow in Java. So they always imply some sort of action. Obviously, we've looked at the setters and getters before. Compare to is also a very common thing, and we will look at this is enforced by an interface which is called comparable interface. Again, getters and setters are very typical, and they directly imply some sort of action. Run fast. Usually this type of actions, which are not directly getters or setters, usually we enforce these by some sort of top level interface, and other classes implement those interfaces so that they are forced to override and provide implementation. I mentioned this naming convention before, is empty. Whenever a method starts with is or has, it means that its return type definitely is a boolean. So, and this is a very, very nice naming convention, because that immediately tells you that is empty means it returns a boolean. It's definitely, so it's tests some sort of condition and returns a boolean that determines whether the condition is true or false. And this also, if everybody follows this naming convention, then it's very easy. If you have an object and you say dot is, the ID autocomplete can quickly tell you which kind of methods in that particular class are using the is. That basically which kind of tests is available to you via the methods that are defined in the object. Typically, a method has a unique name within its class, and so the unique name, remember, unique signature is enforced by the Java compiler. You cannot have two different methods, two separate declarations or definitions for a method that has the same name. That's not allowed, right? You can overload methods, but overloading methods, which means you have two methods that have different signatures. So a method has to have a unique signature, and it's not just for Java, it's any program like C++. The uniqueness is enforced by the compiler, uniqueness of the signature. However, a method might have the same name as other methods due to method overloading. So we're saying that name can be the same, but the signature has to be different, which means if two methods have the same name, their parameter types and the number of parameters or the type of parameters, something has to be different in the way that the parameters are declared in the definition, because return type, the access modifiers, this kind of stuff, they're not part of the signature. So if we want to overload methods, the signature has to be different. So what is overloading methods? This is the topic of the next lecture. So I hope you enjoyed this one. Please stay tuned, and I'll see you in the next one.